Hello friends, in this video lecture we are going to discuss about divergence, curl, Poisson and Laplace equation. It is part of engineering physics and I am Pankaj Jain, assistant professor in physics from Engineering College Bikaner. Let us move on topic. Let us move on topic. First we are going to define divergence of a vector field. Some examples of vector field are electric field, magnetic field, and gravitational field, etc. These fields are called vector field. Electric field itself a vector, magnetic field is itself a vector, gravitational field is itself a vector. These are example of vector field. Okay. Let us now define divergence of a vector field at a particular point. We should we should keep in mind that divergence is defined at a particular point. Okay. It is defined as net outward flux from the surface enclosing that volume per unit volume. Okay. If let us see this diagram, if we have to define divergence of vector quantity at the center of cube, center of this infinitesimal volume element that is taken as a cube, then we should measure first we should measure the net outward flux, that is a dot ds, integration of a dot ds, and then we divide it by volume element dv. Also we will apply a condition limit dv tends to 0. Then this whole quantity is called divergence of a. Okay. Then what is divergence? Divergence at a particular point is defined as net outward flux per unit volume. Net outward flux per unit volume. Also we are applying a condition according to which the volume element should be taken infinitesimal small, so that we can move very close to the point at which we have to find divergence of that vector quantity. Okay. Let us move on next page. If a is given in the form of components, that is a vector is written as ax I cap plus ay j cap plus az k cap, then divergence of a may be calculated by some mathematical analysis which is not included in our syllabus. Only we have to keep in mind the formula, and the formula for divergence of a is what? It is del Ex upon del x plus del Ey upon del y plus del Ez upon del z. The value of divergence, this is the value of divergence in Cartesian coordinate system. Okay. Note that divergence of any vector quantity is a scalar. Divergence of any vector quantity is scalar because flux is a scalar quantity. Because divergence is defined as in terms of flux, and flux is a scalar quantity, therefore divergence of any vector quantity is itself a scalar quantity. Let us know about the physical significance of divergence. If divergence of a vector quantity at a point is positive, then a source of that quantity is present at that point. If divergence of vector quantity is positive, then a source of that vector quantity is present at that point. Let divergence of E is greater than 0. Divergence of electric field is greater than 0. It implies flux is coming out from that particular point. And if flux is coming out from that particular point, a positive charge should be present at that point. Positive charge should be present at that point. Therefore, if divergence of a vector quantity is positive, then a positive charge or a source should be present at that point. Okay, let us move on next page. If divergence of a vector quantity is negative, then a sink or absorber should be present at that point. Okay, for example, divergence of electric field is less than 0, then field lines will approach to that point. Therefore, it should be a negative charge. Negative charge should present at that point. Here I have shown diagrams to illustrate physical significance of divergence. If there is a positive charge, then divergence of E will be positive because field lines will come out from that particular point. If there is a negative charge, then field lines will approach towards that negative charge, therefore flux will be negative and hence divergence will be negative. And now let us consider magnetic field. Magnetic field are always closed curve. All we know that magnetic field lines are closed curve. Inside the magnet, field lines move from south to north pole, and outside the magnet, field lines moves from north to south pole. Therefore, magnetic field lines are closed curve. Magnetic field lines are closed curve. If we take a closed surface in magnetic field, then field lines entering in this closed surface will equivalent to field lines exiting from this surface. Therefore, divergence of magnetic field is always equal to 0. Here I have taken it as third point. If divergence is 0, then neither source nor sink will present at that point. Okay. Magnetic poles always present in pair. Therefore, divergence of magnetic field is always equal to 0. Okay. Now I am summarizing my talk about physical significance of divergence, that if divergence is positive, a source will present at that point. If divergence is negative, a sink will present at that point. If divergence is 0, neither source nor sink will present. If both are present, then strength of both poles will be equivalent. Okay. Now we are going to define curl of a vector quantity. Let we have to define curl at a particular point in space. What we have to do, we have to surround this point by a closed curve, as shown in diagram. Also, the area bounded by this curve should be infinitesimal. Okay. Then how we can define curl of a vector quantity? It is defined as circulation of that vector quantity along closed curve, that is line integration of uh, vector A along closed curve per unit surface area, that is divided by 1 upon ds. Also, we are applying a condition according to which we have to taken the surface area infinitesimal. Therefore, curl of a vector at any point is defined as it is equal to circulation of vector quantity. This is circulation of vector quantity. Okay. Circulation of vector quantity per unit surface area surrounding that point, where surface area should be taken infinitesimal. Surface area should be taken infinitesimal. Okay. This is a definition for curl of vector quantity. We should keep in mind that curl of A is a vector quantity. In above definition, we have only give its magnitude, but it is a vector quantity and direction of curl A will be perpendicular to the uh, bounded surface bounding surface enclosed by the curve. Therefore, if the surface is in xy plane, you can see this diagram that I have taken the closed curve as well as surface bounded by that closed curve in xy plane, then direction of curl A will be in z direction, because closed curve or surface is in xy plane. Therefore, curl of A will have z direction. Okay, curl of A is a vector quantity and its direction is taken perpendicular to the perpendicular outside the surface. Okay, let us move on next page. If we want to define curl in Cartesian coordinate system, then it is given by determinant as shown in this page. Okay, determinant of I j k del upon del x del upon del y del upon del z ax ay az, which may also written as I cap del ax upon del y minus del ay upon del z. Sorry, it is I cap del az upon del y minus del ay upon del z plus j cap del ax upon del z minus del az upon del x plus k cap del ay upon del x minus del ax upon del y. Okay, it is very simple and one can remember it by determinant. Okay, there are two important note. If divergence of A is 0, then A is called solenoidal vector. Okay, if divergence of A is 0, then it is called solenoidal vector. And if divergence if curl of A is 0, then A is called irrotational vector. These are two important note and questions appears in examination on the basis of these two notes. Okay, let us move on next page. Now we are going to study Poisson and Laplace equation. All we know that according to Maxwell's first equation, that is divergence of E is equivalent to rho upon epsilon naught, and relation between electric field and potential is E equivalent to minus gradient of V, that is minus del V. Okay, this is the relation between electric field and electric potential. If we use equation 2 in equation 1, what we get? We get dial, you can see equation 1 again, dial dot minus del V is equivalent to rho upon epsilon naught. Dial dot dial can be written as del square. Therefore, del square V is equivalent to, negative sign is transferred in right hand side, is equivalent to minus rho upon epsilon naught. This equation is called Poisson equation. This equation is known as Poisson equation, and this equation gives relation between electric potential and charge density. Okay, electric potential is V and charge density is rho. Okay, let us move on next page. Let us consider, if space is charge free, there is no charge in space, then charge density will be equivalent to 0, that is rho is equivalent to 0. Therefore in Poisson equation we can put rho equivalent to 0. Then what we get del square v is equivalent to 0. This equation is known as Laplace equation, where del square is called Laplacian operator, and value of del square in Cartesian coordinate system will be del 2 upon del x2 plus del 2 upon del y2 plus del 2 upon del z2. Okay. With the help of these equations, Laplace equation and Poisson equation, we can find electric potential. One can find electric potential, we can find V, as well as we can find charge density when other quantity is known. That is, if charge density is known, then we can find electric potential. If potential is known, we can find charge density. Okay, students, this was an introductory lecture about divergence, curl, Poisson and Laplace equation, which is part of electromagnetism. Thank you.